Hello and welcome. Thank you for joining us today for this AI Data Analytics Reimagined virtual seminar. We've got an exciting hour planned for you today with rich, actionable content that you can learn from and apply to your business and realize the benefits of AI and data analytics. I'm Aaron Chasen. I'm the Vice President of Products and Solutions Marketing here at Dell Technologies. And over the next 20 minutes, I'm going to be sharing with you how we can accelerate intelligent outcomes everywhere with AI for businesses of all kinds and in all industries. Immediately following that, we're going to have the keynote session. We're going to have a great lineup of speakers from a variety of our top partners, ecosystem partners, that are going to have 40-minute breakouts diving into different aspects of artificial intelligence and how they can help you streamline your AI innovations. So we're very excited to have you, and let's go ahead and get started. So this idea of accelerated intelligent outcomes is something that we're really investing heavily in here at Dell Technologies, and we're working closely with ecosystem partners to have solutions that can help you drive or unlock the value of artificial intelligence for your business. Acceleration, of course, has to do with both the speed at which you as a business move forward, but also the speed at which you can execute and roll out these new jobs, these new products and portfolios within your company. And the systems that we're now deploying with artificial intelligence are making decisions faster than we've ever been able to do before, solving problems across many different industries and verticals. Now, like I said, it's happening across almost every different company that's out there, whether it's automotive to healthcare, from farming to pharmaceuticals, sporting goods stores, retail outlets, robotics, you name it. Companies across almost every industry are leveraging artificial intelligence to make decisions faster, more efficiently, and provide more economics of scale for companies moving forward. Of course, the challenge is that for many companies, artificial intelligence, while we've been talking about it as an industry for many years, actually getting started is fairly difficult for some because it applies to a new set of skill sets, requires new technologies to be able to really get the value out of what AI can provide to companies. And so we did Tech Republic recently did a study that actually showed that some companies are struggling with this a little bit. In fact, 53% of the respondents said that business users really aren't clear about what they expect to get out of these AI and ML projects. It's really a bit of an indication that there's sometimes a disconnect between the IT organizations, the line of business, the data scientists and app developers that all really need to work much closer together before we even get started into these projects to make sure that those outcomes are successful as quickly as possible, showing value to the business so that you can then scale these opportunities to other organizations within the company. And of course, the key thing here as well is that IT departments, as a result, have kind of said, hey, we want to do this. We want to support the business to be able to move into this direction. But these projects are going to be a little bit more challenging than some of the IT projects in the past. And they want to work much more closely with the business to ensure positive outcomes. And of course, Dell's here to help with our customers and be able to successfully do this. And if you think about it, we've kind of put together our own sort of hierarchy of needs. So similar to Maslow's hierarchy, we've got this IT hierarchy of needs that you need to be thinking about across all these different pieces before you even get started in deploying these projects. So the first thing we need to be thinking about is the use case. What is the problem that you're trying to solve, right? Is it making a particular process more efficient or faster? Is it eliminate a constraint in a manufacturing process? Is it get better crop yields out of a farm or a plot of land? Is it have better error detection or quality control in a manufacturing line? These are problems that people are applying AI to across many industries in order to be able to solve those challenges and drive value for the business. So that first thing is, what's the use case we're going after? What's the strategic impact if we're successful in that? Is it feasible? Do we have the skill sets? Do we have the technology? Or if we don't, do we have the ability to go and get those things to get started? How are we going to measure that success? What are the KPIs? What are the things that we can report back to the business to show the value that this has produced? And of course, at this level, do you have the right executive stakeholder support and buy-in so that if this is a success over time, we are able to amplify that and leverage that more broadly across the broader organization? Once you've identified that use case, the next thing you need to be thinking about is, what's the data that's going to be required in order to be able to do this analysis? Do I have that data? Do I need to go and get more data? Where does it reside? Is it on-prem? Is it on the edge? Is it in the cloud? What are the things that I need to be able to curate that and prepare that data? Are there any constraints that I need to be aware of? Regulatory requirements, data gravity challenges that I may need to overcome. So understanding what data you have, where it lies, and how you can get access to it is absolutely critical and requires a partnership between the data scientist that has an understanding of what they need and potentially the data architect that understands where and how we can get access to it. Once we've identified that piece of it, the next step is to move towards really more the world of the data scientist, which is what model do we want to use? What is the analysis that we're going to be making against this data set? What's the approach that's going to work best? What task do we want to use? Do we want to use anomaly detection? Do we want to use a natural language processing? What is the particular AI model and task that we want to apply to solve this particular problem? Which tools will the data scientist use to build, to train, to prove out that model, to make sure that it's the most accurate representation of what we want to be going and looking for as we push that model into production? And that leads us to the next piece. How do we push that model into the production? How do we push it to where we're going to be doing the actual inferencing? Whether that's on-prem or off-prem, do we have the right capabilities to be able to push that model from test dev, from model training, and out into a production environment? Are we using monolithic or cloud native methodologies and application development systems? If we're moving more towards that cloud native approach, do we have a right CI/CD model in place to be able to progress and move that model from development to production and back into that development stage when we need to iterate against that model over time? And then finally, what's the underlying IT environment that's going to be needed to support this? We live in a hybrid cloud world, so we need to be able to think about where that data exists, where we may want to train it, and where we may want to do the inferencing. That may happen on-prem in a private cloud, in a public cloud, or increasingly as we shift more towards real-time data ingest and real-time analytics as those data streams are being created, we need to move compute and move applications out into these edge environments to be able to provide faster, more real-time analytics against data at the point of generation. So understanding whether it's a private or public cloud and what are the latency and throughput requirements that we may need to architect around or be able to understand is a critical piece of this as well. Once you've got these pieces together, we know what we want to accomplish and what the expected outcomes are and how to measure that. We understand what data we need, the models we want to leverage, how we're going to push it from development to production, and understanding the entirety of our edge to core to cloud landscape. That now gives us the ability to start moving forward with that IT initiative or AI initiative. So that next step is identifying what is that use case, right? So typically what you want to look is feasibility first. Can I actually do this? How difficult is that going to be? It's a great idea to obviously start with a smaller project that is a higher probability of a positive outcome to prove the model, to gain the skill sets that you need in order to be successful. And then also when you identify a couple of use cases, which ones are going to have the highest strategic value or strategic impact? Because if we can get one that's going to be what we believe relatively easy to be able to be successful in, and it has a higher business impact, that's going to get higher visibility within the organization and give us more of an opportunity to get the funds that we need to be able to expand these AI opportunities out to other aspects of the business. So the first thing you need to do is figure out within your sector, within your organization, what is the right use case that we want to go after? Now the number of use cases are legend out there. I mean, what you see here is simply a small subset of the overall set of use cases or opportunities that you may be able to solve, from fraud prevention in financial services to video surveillance in the public sector to condition monitoring in manufacturing. So looking through and maybe doing a little research on the different types of use cases or values that AI can do within your market could give you an idea of where you might want to get started. Once you've identified what it is that you want to do, of course, as we said before, what are the tasks that you want to apply to that, right? So there's a variety of different AI algorithms that you can use to be able to run these applications to really get value. But what you see here is all of the ones that are highlighted in a dark blue are showing you different types of use cases that are solved via anomaly detection, right? That's the common AI algorithm that we're being used against all of these different. So while the use cases may look different to the naked eye, from a data scientist perspective, they're all solving a similar problem. So what's an example of anomaly detection? It's basically this idea of training a model to know what it expects to see and then be able to alert based on an anomalous or unexpected event. One example might be maintenance for escalators, right? So I might train a system to be able to listen to how the sounds of that escalator that it's making on a regular basis and understand what normal sounds like. And if all of a sudden we hear squeaks or pops or different sounds that are unexpected, it can notify the maintenance crew to go and do some predictive or early maintenance on that, so you don't have larger cost break fix further down the road. Probably one of my favorite is what's happening in the world of network security, right? If you go back not too long ago, network security was all about what I kind of referred to as the Middle Ages. It was putting up a big firewall surrounded by, a moat and different types of things to keep people out. And then the terminology used, literally tunneling through that with VPN to get access. The problem, of course, is that attackers got pretty smart to this, and we've gotten to the point where even with all the perimeter security capabilities, you've really got to assume that there are certain intruders that are in your systems at all times. And so we really need to treat networks more like a modern city, where there's activity going on at all times. And by applying an anomaly detection AI algorithm, we can learn what normal looks like on a network, normal behavior in traffic, and then identify anomalous behavior to notify a security team if there might be somebody that's doing something unexpected that could be a threat to the business, right? So this idea of anomaly detection really can be applied to many different areas, and it's really working with that data scientist to identify what's the right task for your particular AI initiative. The next piece is really being able to understand how quickly can we take that from test dev to model training to production, and being able to merge the AI models with the applications and the processes the business use to transact everyday business. It's important to make sure that you put a good pipeline in place. And you can see later in a breakout, Aguazio, for example, has helped solve some of that DevOps CI/CD pipeline capabilities to help you move and merge these data models into the application stacks for production level processes. The final thing before we start thinking about the underlying infrastructure is making sure that we understand that this is happening everywhere and at all times. I mentioned earlier, we're living in a hybrid cloud world. So the ability to support multi-environment operations is absolutely critical. And data collection is going to be pulling data from wherever it may reside, at the edge where increasingly real-time data is being generated, pulling that back into the core or into the cloud, or there's a lot of data that's being generated in the cloud itself that we would need to integrate with that edge data to be able to build a rich, robust model to be able to analyze against. These decisions are not unique to any different customer, but you need to figure out what the right architectural design is for you and be able to have a variety of infrastructure capabilities, whether that's in a pristine data center or in a rugged, dirty, mining facility in a remote part of Australia. You need to make sure that you've got the right systems across those different landscapes and the right software to be able to manage and control that wherever your data may reside and wherever those applications need to run. So let's take a deeper look at sort of the infrastructure requirements that these AI systems, what the impact they have on the systems that you need to deploy them on. The first one is to understand that there's basically three basic phases. There's the staging phase where I prepare the data to be analyzed, and I'm staging data that's being pulled from a variety of locations. The second phase is going to be that model phase, which is going to be creating the model that I'm going to then be running in production. And then there's the inferencing phase, which is the actual act of doing that analysis and making decisions based against the model that was created. Now, in the staging phase, the important thing to note here is that we're talking about massive amounts of data being pulled from a variety of different data sources. So being able to access that, prepare it, curate it, catalog it. The types of things you need from an infrastructure is obviously capacity. How do I manage and store and protect the amount of data that I need to be doing to be building these models off of? The other thing is to make sure that we understand that there's a broad variety of data that we're typically going to be needing to use and pull together in order to be able to build these models. A quick example might be something like farming. So if I want to make sure I maximize crop yield in a field, I'm going to need both structured data, things like temperature and time and humidity, maybe ground density, mineral content, but I'm also going to need to pull that together with unstructured data, right? I might have microphones in the field that listen for crunching. Are we being attacked by a swarm of cicadas? I might want to pull information from satellite imagery to give me thermoimagery, satellite imagery, and pictures, and be able to merge both that unstructured data as well as that structured data to give a richer understanding of the overall farming process, giving better insights to the farmer on how they should be able to plant, maybe water, density of seed into the soil to be able to maximize that crop yield for their particular field. The next thing is, once we've got that data staged, is the model development side of this. Understanding the iterative batch process. So here what we need to do is, typically building a model means iterating hundreds, thousands, tens of thousands of times against the data set and to be able to get a perfect model that we want to roll out into production. This requires concurrency, it requires processing power to iterate rapidly, so sometimes servers with accelerators, and then also significant throughput because we have to feed those accelerators with data. Otherwise, you're not being able to leverage that investment as powerfully as possible. In the inferencing phase, this is about scaling to production, merging into organizational workflows, which are typically software-based operations. But from an inferencing and the infrastructure perspective, this is where pure power is required. Minimal latency, maximum throughput, analyze data as rapidly as possible. So you're talking about CPU dense or accelerator based server systems to be able to rapidly come to a decision based on the model that was created. What that means from an infrastructure perspective, of course, is that we need to make sure from a data staging side of it, we've got storage dense servers to meet the capacity requirements, maybe running software defined storage on top to support multiple data types. You could also, in very large data set requirements, leverage things like Isilon or PowerStore or PowerScale, the ability to be able to store massive amounts of structured and semi-structured and unstructured data, but also have the performance to deliver that to the model training in the next phase. In model and development, you need to apply compute dense servers versus storage dense because we need to be able to iterate very, very rapidly when we do that model building process. So we're talking servers with accelerator cards, and then potentially, again, that Isilon All Flash gives you the ability to feed those GPUs the massive amounts of data very rapidly in order to build those models as effectively and efficiently as possible. And then finally, once you roll those out into the production, you need to be thinking about servers that are more lightweight. They don't require as much capacity because there's not as much data you're going to be feeding it, but I need to be lightning quick with CPU power and accelerator power to be able to make sure that we're making those decisions as quickly as possible. Also, if you're putting this in tougher environments, having ruggedized systems is something that might be in a consideration depending on your use case. Network interconnect is of course important. We need to be able to pull these things together and connect that across a wide variety of locations. And what we found is we're moving towards more of an open networking environment, which drives cost out of the network infrastructure, connecting your edge, core, and cloud environments. And then finally, of course, you've spent a lot of time and money building these models. The last thing you want to do is lose the model, right? Whether that's accidental or through external attacks. So cyber recovery and data protection is critical. We're getting short on time, so quickly as we go through it, what we did find is that companies and customers that use these systems that are built for AI actually get much better quality, much better capabilities, much better results than those that don't. In fact, 18% on average get more customer spend, 19% faster decision-making, 16% average cost reduction. Think of it as being in typically single-digit benefits, and any of these could be game changers, but to get significant double-digit advantages can create a significant competitive advantage for you and your organization. The final thing just to note is if you need help, we've got labs and we've got people that can help you out. If you want to see things in action and get a feel for the technology, Customer Solution Centers are here to help you do technical briefings, proof of concepts, and workshops. If you need help from experts, we've got data scientists, engineers on staff, and the PhD SMEs in our HPC and AI Innovation Lab that you can actually go in and actually bring your algorithms and models with you, test them out on equipment, even equipment that may not be released to the market yet, so that you can fine-tune your operations, fine-tune your models, and when those systems come to market, you can immediately start leveraging them and de-risk that operation. Finally, if you need any help beyond that, we of course have a rich services ecosystem of Dell Technology Services, global systems integrators, channel partners, boutique operations for verticals or geographies, and we can connect you with the right group of people to help you get started wherever you may be in the world. So hopefully you understand a little bit of kind of where we're coming from here. We're looking to help you align business and IT to a data-first culture. We want to help put any data to work anywhere and any way across your edge core cloud landscape. And through deep partnerships and technology specialties, we want to make sure that you're able to sustain that competitive advantage as you grow and expand your business over time and leverage AI more aggressively within the business. Next steps, of course, if you need any assistance on identifying what your business requirements are or put the business case together, consulting services can help you with that. If you want to prove out the models you already have, solution centers and innovation labs are there for you to leverage. And if you've already got everything in place and you're just simply looking to understand what technology is out there to get started, reach out to your sales team or organization, and we can help you get in touch with the right AI specialty and consultants. So with that, I want to thank you. The next step in this seminar session is to go into a breakout room I'm about to give you a link to, where we've got our key strategic partners from Cloudera, SAS, NVIDIA, and Iguazio are going to help you understand some of the deeper dives into the different aspects that they can help you be successful with your AI outcomes. So with that, if you look into your chat window, the link that you see here on this screen is available to you. Click on that chat window. That'll bring you to a launch page where you can then choose which breakout you'd like to attend. And just click on the launch now. And hopefully I'll be joining you in one of the rooms. And I hope you had a good day and get a lot of value out of this seminar today. So thank you for your time.